Hello everyone. Happy Ganesh Chaturthi belatedly, and thanks for watching my videos, and thanks for subscribing my channel RPS videos. Let's start our session. Class 10 physical science, physics topic, electricity. Previous session we already discussed some concepts like electric potential and potential difference, and today our topic is electric current. Today our topic is electric current. So electric current is nothing but the flow of electric charges. The flow of electric charges are called electric current. So when two charged bodies, when two charged bodies at different electrical potential are connected by a metallic wire, then the electric charges can flow from one end to the another end, means from higher potential to lower potential, higher potential to lower potential. So this flow of charges in a metallic conductor or in a metallic wire is called as electric current. So it is the potential difference. Electric current is the potential difference between the ends of the wire, which makes the electric charges can flow in the wire. So the potential difference between the ends of the wire, between the ends of the wire. So due to the potential difference, then the electric charges can flow. The electric charges can flow from one end to another. So for example, if it is electric wire or metallic wire, so let us consider A and B. So between the A and B ends there is some potential difference. So as earlier we discussed what is potential difference. Potential difference is work done. The work is done to move potential from one end to another end, to move a unit positive charge. Work done required to move a positive charge from one end to another end. So higher potential to lower potential. So as earlier we discussed, the potential difference is amount of work done is in moving a unit charge from one point to another point. So work is done for moving one charge from one point to another point. So why do the work is done to move a charge from one end to another end? So from higher potential to lower potential, higher electrical potential to lower electrical potential due to the difference in potential difference. So due to potential difference between the ends of the metallic conductor, that potential difference in a metallic conductor makes the electric charges can flow from one end to another end. So that flow of electric charges is nothing but electric current. So conventionally, while the electric current is discovered, then scientists don't know about the electrons. So simply they say that electric current means the electric current is a flow of electric charges. They don't know they are the electrons, those types. So electric charges in a conductor such as a metallic wire. So the electric current is a flow of electric charges. So what type of electric charges? Negatively charged particles or negative electric charges in a conductor such as a metallic wire. So the magnitude of electric current in a conductor is the amount of electric charge passing through a given point of the conductor in 1 second. So electric current is amount of electric charge. So here we can take in amount of electric charge by time. So in 1 second. So how much electric charge is passed through a metallic conductor in a second is called as electric current. So electric current is represented with the I. So electric current I is equal to Q by T. So amount of electric charge by the time. So in a 1 second. So the SI unit is ampere. So the magnitude of electric current flowing through a conductor is given by I is equal to Q by T. The SI unit of electric current is ampere. So it is a scientist name. So what is meant by 1 ampere? So 1 ampere means when 1 coulomb of electric charge, as we know, coulomb is the SI unit of electric charge. Coulomb is SI unit of electric charge. When 1 coulomb of electric charge flow through any cross section of conductor in 1 second, the electric current flowing through it is said to be 1 ampere. Sometimes, so that's why you can write 1 ampere is equal to 1 coulomb by 1 second. 1 ampere is equal to 1 coulomb by 1 second. Sometimes a smaller unit of current also we can use, that is milliampere. So we can write small m, capital A. So that is equal to 1 by 1000 amperes. So 1 milliampere is equal to 1 by 1000 amperes. This could write as 10 power minus 3 ampere. So 1 milliampere is equal to 10 power minus 3 ampere. So the small quantities of current are expressed in the unit of milliamperes. They are very small quantities of current are expressed. Still the smaller unit called microampere. Mu A. So mu A is equal to 10 power minus 6 ampere. a conductor in a 1 second. So amount of electric charge passed in a conductor is called as electric current. So if 1 coulomb of electric charge is passed through a conductor in 1 second, we get termed as 1 ampere. The SI unit, the small unit is milliampere. The very small unit is microampere. 1 microampere is equal to 10 power minus 6 amperes. 1 milliampere is equal to 10 power minus 3 amperes. So to measure the current in a circuit, to measure the amount of current is flowing to a conductor, we have to use a device is called as ammeter. We have to use a device called as ammeter. So ammeter is a device used to measure the current. So this is connected in a series. This is connected in a series. So the ammeter connected in a series in a electric circuit. So this is about what is meant by the electric current. How do we get a continuous flow of electric current? How we get a continuous flow of electric current? How we get a continuous flow of electric current? So as just we discussed, due to the potential difference between the 2 points in a conductor, then electric current flows from one end to the another end due to the potential difference. So the simplest way to maintain a potential difference between the 2 ends of conductor as to get a continuous flow of current is connected to a conductor between the terminals of the cell or battery. So if it is a conductor, so points A and B. So if it is a conductor, so the conductor has some potential difference to maintain the continuous flow of electric charges, to maintain the continuous flow of electric current in a conductor. The conductor must have the potential difference. This potential difference between the conductor should connect it to the terminals of a cell or battery. When we connect to the terminals of cell or a battery, then there is a continuous flow of electric charges takes place. So as we know, the flow of electric charges in a conductor is called as electric current. So a potential difference is maintained between the terminals. A potential difference is maintained between the terminals, and the potential drives the electric current in it, which the cell or battery is connected. For example, a single dry cell or a battery is have a potential difference is 1.5 volt. So potential difference of a cell or a battery, a single cell or a battery has a potential difference of 1.5 volts between the two terminals. So when a dry cell is connected to a torch bulb with a copper wires, through the copper wire, the bulb, due to which the bulb lights. So if here through this copper wire, if we connected a battery or a bulb like this. A bulb. So a bulb is glows. A bulb is glows because of the potential difference. Due to that potential difference, electric current is flows in the circuit. Electric current is flows in the circuit. So torch bulb through copper connecting wires, the potential difference causes the electric current. The potential difference causes the electric current flow in the through the conductor and the bulb is glows. Here, in order to maintain the current in the circuit, the cell has to expand the chemical energy which is stored in it. So, to maintain the flow of electric charges, a cell or a battery must contain some chemical energy. That chemical energy must be utilized and convert into electrical energy, and then the flow of electric charges takes place in the circuit, and a potential difference maintains continuously. Due to the potential difference in the ends of the conductor, so here the bulb acts as a conductor. Sometimes the bulb is also called as a resistor. Sometimes the bulb is also called as a resistor. So between the two ends there is some potential differences happen. Due to that potential difference, the current or the flow of electric charges takes place. To maintain the current flowing, the cell must expand. The cell must utilize its chemical energy. That chemical energy must be converted into electrical energy. So clearly from the above discussion that a common source of potential difference or voltage is a cell or a battery. A cell or a battery. It can make the current flow in a circuit. So a cell or a battery has potential or voltage. A cell or a battery has some voltage. So due to that voltage, the flow of electric charges takes place in the circuit. So then the current flows continuously. Okay. Now, in which direction then the current flows? In which direction? What is the direction of electric current? In which direction? Right. So as we discussed about electric current and what we have to do to flow the electric current continuously, we already discussed. So there must be a potential difference is required. A potential difference is between the two ends of the conductor is must. So due to that potential difference, then the flow of electric charges takes place. Then the current flow continuously in the electric circuit. Now, what is the direction of electric current? So next topic is direction of current. In which direction the current flow in the circuit? In which direction the current flow in the circuit? When electricity was invented a long time back, it was known that there are two types of charges, positive charges and negative charges, but the electron has not discovered. At the time. So, electric current was considered to be a flow of positive charges, and the direction of flow of charges was taken to be the direction of electric current. Thus, the conventional direction of electric current from positive terminal to negative terminal throughout the circuit. So, if it is if it is the electric circuit, so maybe you have to use a bulb or something, whatever. So bulb glows when we connected in the circuit. So the direction of electric current is from positive terminal to negative terminal. Positive to negative terminal, because while the current is invented, so those times there are only two types of electric charges. They are positive charges and the negative charges. Those times still the electrons are not discovered. So all are considered electric current is nothing but the flow of positive charges. So in which direction the positive charges can flow in a conductor. So that is the direction of electric current. Conventionally, from those time onwards, so consider that the flow of electric charges in a cell or a battery is from positive terminal to negative terminal. So in our circuit diagrams, we put arrows to the connecting wires pointing from the positive terminal to negative terminal of the cell to show the direction of conventional current. Actually, the flow of electrons is from negative terminal to positive terminal causes the flow of electric current. Conventionally, considering that from positive terminal to negative terminal, but actually when the electrons are the negatively charged species or negatively charges can flow from negative terminal to the positive terminal, the current can flow. That's why whenever we switch on any electrical appliance, the electrons or the negative charges can flow from electric appliance to the switch. How the current flows in a wire? Flows in a wire? What is the direction? What is the reason the current flow in the wire which is connected in a circuit or which is connected to the cell or a battery? Right? Let us discuss. So we understood that how the current flows. How the current flows in a wire. So, as earlier we discussed, a metallic conductor has some cross section. Consider that this is a metallic conductor. Or simply we can say that the metal conductor or a metal wire. So, as we discussed, metals are the good conductors of electricity because of free electrons are present. So, in a conductor or a metallic wire, electrons can flow or can move in a cross section randomly. So, they move in different directions. Randomly they can move. So they did not have any particular direction. They can move as them. So due to the random movement of electrons, in a conductor or a metallic wire. So the two scientists named as electrons in their particular space. So that particular space is called as lattice. That particular space is called as a lattice. In a lattice, electrons are moves continuously in a different directions. Electrons are moved randomly in their lattice, so in different directions. So due to this random movement of electrons, so if this metallic wire is connected, if the metallic wire is connected to a cell or a battery, the random movement of electrons or negative charges can move in a particular direction. So they can move in a particular direction from negative terminal to positive terminal. So here random movements, the electrons are moves randomly when the metallic wire or the conductor connected to the a cell or a battery, or a source of electricity. When a source of electricity like a cell or a battery is connected between the ends of the metal wire, the electric force acts on the electrons present in the wire. Since the electrons are negatively charged, then they start moving from negative end to the positive end of the flow of positive end. So when the metallic conductor is connected, electric field is formed. Due to that electric field, electric force is applied on the electrons. So as we know, electrons are the negatively charged particles. Due to the positively charged force, nothing but the electric field or the electric force, they can move in a conductor from negative terminal end to the positive terminal end. So actually the direction of flow of electric current in electric circuit is from negative terminal to the positive terminal. But conventionally we can say that so flow of electric charges, nothing but the flow of positive charges from positive terminal to the negative terminal. From positive terminal to the negative terminal. So how the current flows in a wire? So in a metallic wire, the negative charges, nothing but the electrons are moved randomly in a different direction. When this is connected to a source of electricity like a cell or battery, due to the electric forces, due to the electric field, these electrons can flow in a particular direction, from negative end to the positive end. So here the electrons are the negative particles, negative charges are maintained or can flow in a metallic wire, or in a metal conductor. So with a constant average speed or average velocity, electrons in the conductor can flow with the constant speed or the constant average velocity or the average speed. So that average speed or the average velocity of the electrons are called as drift velocity. Drift velocity. Drift velocity is the average speed and the average velocity of electrons in a conductor. So we can write as drift velocity Vd is equal to, the value is 7 into 10 power 5 meter by second. Drift velocity meter by second. So drift velocity means the electrons in the conductor move with a constant speed or a constant velocity. So that constant speed or constant velocity is called as the drift velocity of electrons. Drift velocity of electrons are Vd is equal to, we can write that value is 7 into 10 power minus 5 meter by second. So this is about electric current, direction of electric current, why the flow of charges are takes place, in which direction the current flows, and how the current is flow.